So welcome on my talk. My name is David Vávra. I'm from Prague, and today I will talk about these cool buzzwords: Firebase, Kotlin, RX Java, and MVP. I would like to clarify at the beginning that this is more like advanced talk. If you don't know, if you never heard about these technologies, you will probably not understand. So first I would like to ask, who is Android developer here? Most of you, great. So this is Android specific talk. I will talk a little bit about some cross-platform stuff, but it's mostly about Android, about our app, how we are developing with all these technologies. So let's dive into it. So something about me. I worked at Avast for 2 years before I worked at InMight as Android developer. And this February, I founded my own company called Step Up Labs. I had this hobby project for like 5 years since my university time called Settle Up. In Czech, it's called Dlužníček. Maybe you know it. Who knows Dlužníček? Hey, I have some users here. So it was my hobby project for many years, and it grew so big. We have now about 200,000 active users on Android and iOS. So I decided to quit Avast, and I'm now working fully on this, and we are 7 in our company. I'm also a Google developer expert for Android, so I speak a lot on various conferences, and I'm also organizer at GDG Prague, so I'm also helping with community events like this one. So first, I want to talk you a little bit about our app. Some of you know it. So this is how it looks today, Settle Up. On the left, you can see the Android version. On iOS, you can see on the right, you can see the iOS version. The app is about shared expenses. So it means that when you go to some trip with your friends, somebody pays for accommodation, somebody pays for gas, for beers, and you input all these expenses into the app, and the app calculates who owes who how much, who should pay next. So it's quite helpful for some people. We already have it in the Play Store, but you can see the design is completely different on both platforms from historical reasons. So we decided to redesign the app completely. And this is how it will look in few months. We are already working on it. So this is designed from Android version. We are using colors for each group. So each group will have different color. And when we were thinking that like we are redesigning the app, so we have to rewrite most of the code. So let's look at some architecture. Let's make the code more modern and more stable. And so we looked what's cool among other developers. We read many articles, and we considered some architecture choices. So now I want to talk about what we were considering to using for architecture, and what's the benefits and disadvantages of all this. Finally, you can hear me. No air conditioning. Okay, so first we were thinking about backend, of course, because our app synchronizes. We are multiple users. You can see expenses of other people. It's made for groups, so we need some backend. So currently, we have our own server. It's running on App Engine in Java, saving data into data store, and nobody from our team is backend developer, and like developing backend is a huge pain for us, and nobody wants to do it. And we don't want really to hire backend developer. We want to focus on the UI, on the client side, and like make it really cool. So when Google introduced Firebase, it was really interesting for us. Or it was even before Google I/O, Firebase existed as a startup which Google bought. So we are looking at Firebase. And finally, we decided for it, and why? Because mostly 2 reasons. One is synchronization, and one is offline. In our current code, with our own server, we had to create our own synchronization logic, and it's quite hard to do, because mobile networks are really you cannot rely on them, and there are really some weird edge cases where something doesn't synchronize or duplicates, and Firebase solves this out of the box. Like you don't have to write any code for synchronization, and it's really battle tested on mobile networks, etc. And also offline, we had this huge code base about saving data offline and like synchronizing something is offline, something is online, because our app needs to work offline because it's used by travelers a lot where they don't have connection. And Firebase solves this with one line of code. You just say like offline enabled, and it caches all the requests and all the data. So that's really huge. The bonus for us is also real time. So it's really fast. Like we don't need any synchronization button like update now, because it's updating all the time instantly. So that's really nice. But for us, it's like a bonus. Main part is the synchronization and offline. Also, there is an interesting alternative to Firebase called Realm. I think it's the leading like offline-only database for various platforms. Much easier to integrate than SQLite and like do it all yourself. So we are also considering this. But by the time we were considering, they didn't have any server side. It was just offline. But now they introduced the Realm mobile platform, which works similar as Firebase, and you can also deploy it on your server. So if you want to be more in control, you don't want to host it just at Google servers, maybe Realm is also a good option for you. Okay. Then we said that we were rewriting the whole app from scratch, and I saw some various talks on conferences like this about Kotlin, and I got really excited that Kotlin is really nice, concise, modern language. So we were considering if we should switch to Kotlin, and we did. So this is not introduction to Kotlin, but I will say that it's really easier to write the code, maintain the code. It's much less code you have to write. So for example, we use lambdas a lot, we use extension methods, we use nullable types, a lot of functional programming. So I almost never have to write loops. I just call different functions on collections, and it saves us time, and it's really nice. And what's the best about it? That it's developed by JetBrains, so it has full Android Studio or IntelliJ IDEA support, and so all refactoring, everything what you are used to from Java works, and it's also fully compatible with all Java libraries. We are using a lot of Java libraries, and you can even mix Java code inside one project. You can have some Java files, some Kotlin files. It works together. So you can even update just like part of your app to Kotlin, like one screen to Kotlin. And in the beginning, it didn't support Instant Run, which is an Android feature for quickly deploying your code into the device. Now it supports even Instant Run. So it supports everything we need. And there is really no problem with it. Recommend you checking out some documentation. They have really cool one. So then we were considering about like general architecture for our code, because when you are starting new app, you should really think about some architecture. So you can do like traditional way, which is no architecture. That means all your code is in activities and fragments, and is this like huge classes which contain like calling server, saving data offline, displaying stuff, all the logic, and then it's like unmaintainable. I worked at some project at work which were like that, and it was total pain. There were some bugs which were unfixable. So we wanted to avoid that and separate our code into different layers. So there are these two main architectures which people are using, MVP and MVVM. MVP means Model View Presenter. So the main goal is that the activity and fragment, which is the view, so it's really dumb. Like it doesn't do any logic. It just displays stuff. So like it has these methods like set color, and it will just set color on the view, but it doesn't do any logic like when I click this, change this color. No, this logic is done in presenter. So view just calls methods in presenter. Presenter does the logic and calls the view back, and view displays something. And the model, that's like rest of your app, like your database, your network. So it's not like just one single class, but it's a lot of classes in different packages. So it's like rest of the app which is not connected with the view and anyway. So you have nice separation with concerns. And MVVM, that's quite similar. The idea is the same. The view is dumb, but it saves you some time for setting things into view, because you are using data binding. So on Android it needs a data binding framework. So you just change some variables in view model. MV is view model, so it's like the presenter, but you directly change data there, and it using the data binding, it automatically changes in the UI. So it will save you writing some code, but I've been testing it, and it really works nice for simple apps, simple cases. Like it really works like magic. But when you have more complex app with animations and you are changing a lot of stuff in the view in some sequence, then it got tricky, and that's why at the end we chose MVP, because we have the code much more in control. We have to write a little bit more of the code, but we have it in control, what exactly should change when. So now we were using in our current app, we are using Google Analytics for tracking all the events people are making in the app and like analyzing performance. And we switched to Firebase Analytics. So it's a new service also by Google, which is made primarily for apps. It makes more sense for apps than Google Analytics. Google Analytics is more for websites. It's really this like huge platform with so many features. And it's for developer, it's quite easy to get lost in the console in Google Analytics. In Firebase Analytics, you don't get lost there. It's really simple. You get all the data you need specifically for the mobile apps. And it has like automated tracking of many events, so you don't have to write any code. The setup is really easy. You just add dependency, and it works. Like you don't have to integrate. You just add dependency. And it has some nice features like audiences or integrations with other Firebase tools like notifications. Like you can send notifications to some audiences from Firebase Analytics. On the other hand, Google Analytics is more robust tool. So for some more complex analysis like funnel analysis or behavior tree, it's better in Google Analytics. But what you can always do, you can export data from Firebase Analytics to BigQuery, and you can do any custom analysis there. Then Firebase crash reporting versus Crashlytics. So we were using Crashlytics library before. We were quite satisfied with it. And we switched to Firebase crash reporting. Firebase crash reporting now is in beta. So it's they don't have all the features as Crashlytics does. So I would say Crashlytics is still a little better. But we switched because it's all integrated with all the other Firebase features. For example, all the crashes become analytics events, and then you can use it in the analytics reports. You can even send notifications to users which had a crash. So that's really nice. Also a much easier setup than Crashlytics. You just add dependency, that's it. What it doesn't have right now, I think Google is working on it, but you cannot, for example, mark some crash as resolved when you're fixing it. That would help a lot. Also, some automatic uploads of ProGuard mapping is not there. Hopefully, they will add it in the future. There is some Firebase Summit on Monday. I hope they will introduce some new features. Then, where to save? Like we are saving the data of users, like the text-based data, into Firebase real-time database. But where to save like images or binary files? So we were looking at Firebase storage and Amazon S3, which is really similar services for saving like bigger binary data of user-generated content, like in our case, pictures of people and receipts. You can take receipts. And we chose mainly because of the price, because Firebase storage is cheaper. The price per gigabyte stored there is 0.026 US dollars per gigabyte, and Amazon S3 is 0.03. So it's a little bit cheaper. Then there is really cool features in Firebase called Firebase Dynamic Links. So currently we have email-based invitations. So that means when you are inviting somebody to group in Setup, you need to know his email. You enter his email and you are granting him permissions to this group. It works, but the problem is you have to know email of your friends, and people are using mostly today like Facebook and messengers, and like they don't have emails. Or you can make it based on phone numbers, but also like people don't have phone numbers of everybody. So it's quite hassle, and it would be much easier if you can just generate link and like send this link to everybody who you need to access this group. And you can use any channel like WhatsApp or whatever. And Firebase Dynamic Links is exactly for that. The advantage is that it survives app installation process. So this link works even after user installs. If the user doesn't have it installed, it goes to the App Store or Play Store. It's cross-platform. And then it goes back to your app after installation, and you still have context where the user has been. So for us, it's like the group ID. We need to know group ID of the group is trying to join, and after installation, we can show him immediately the group. He doesn't have to go through onboarding like new user. We can show him relevant content. Last cool feature from Firebase we are using is remote config. So it's free service, it's awesome. We have been using something similar in Avast quite a lot, and it took like a whole team to develop just this like backend for all this A/B testing. So usually before this was available just for big companies who had resources, and now everybody can use this, even indie developers. So it allows you to do A/B testing and also feature flags. So A/B testing is great for checking some ideas. In your app, you can slightly modify the UI, make it like 50-50, and then measure how users are behaving. So we will be using this a lot for fine-tuning our UI. And feature flags is awesome, specifically in iOS. On Android, you have staged rollouts in Google Play. So you can like release new version on just like 5% and test if it crashes or not. So it's not such an issue, but on iOS, it takes like 2 days to make an update, or 1 day maybe. So, and like if it's crashing, it's really a problem. So you can create feature flag. That means you will update your app with the feature switched off. So for the users, it looks like nothing has changed. But then you can gradually turn on to some specific group of people. So like you can turn on this feature for 5%, test if it works. If it doesn't, you go back to 0%. If it does work, you increase the percentage. So you can use rollouts like this. And finally, Firebase Authentication is really a cool service for signing in into your app, because this is quite painful to do for especially if you want to have multiple providers like Google, Facebook, Twitter, GitHub. So you have to integrate all these services manually, and like it's quite painful, like this auth flows. So what people do, they just gave up and they just integrate like only Google or Facebook, and then they just gave up. And so, and with Firebase Authentication, the integration is done there all for you, including some UI. There is a UI library called Firebase UI, which even does all the screens for you. You don't have to use it. You can. We are using it and modifying it slightly. It saves us a lot of time. Like, we want to focus on our app, not authentication. Authentication is like what every app has to solve, but we want to do our app, and not this. Okay, so let's move on to a second part of my talk, which is about some challenges we were encountering when implementing this architecture. So it will be more about code. I will show you some code of our Android app and how we dealt with them. So first, when you decide to switch on Firebase real-time database, you have to really think hard about the database structure, because Firebase real-time database is NoSQL database, and it looks like, or when you are interacting with it, it looks like one big JSON file. It has API out of the box, and you have to lose a little bit of like relational thinking. Like you don't have tables there and like relationship between tables. It's NoSQL. So you have to really think hard, and the querying is also quite limited on Firebase real-time database. You cannot like do joins or what you are used to from relational database. So you have to really think how you structure it based on your queries. So you have to think before how you will query the database and structure accordingly. Otherwise, you would have to download maybe unnecessary data and like do some processing on the client side. Like it's doable, but it's better to prepare yourself. So here is a part of our database structure. So as you can see, it's like one big JSON. It looks like one big JSON, but on the servers, of course, it's not saved as a JSON. It's NoSQL, but the representation is JSON. So you have this top level nodes, which you can think as like tables. Like it's not tables, but you can think a little bit like, so we have like transactions, groups of users, permissions to groups, and which users are in which groups. So first thing I would like to say that here you have groups, group ID and like name of the group, and also these transactions are related always to group ID. So why not to put this into here? You could do it theoretically, like you can nest things in the JSON, you can put transactions into groups, but it would be a bad idea, because when you have a UI where you're just displaying just names of the groups, like list of names of groups, it would also download like all the transactions, which could be a lot of data. So you always want to flatten your database structure. You want to separate transactions from groups like this. And the second point I want to make, sometimes you have some end-to-end relationships, like here, like permissions of users in groups, and also which users are in which groups. And we have UI which shows both of this information. We have screen which groups are yours, and also in this group what are the users. So we have both of these screens, and for this case we have to kind of like duplicate the data here. So in some cases, quite rarely, but like cases like this end-to-end relationships, you need to duplicate the data, otherwise it will be really hard to query it. So so that means that when like a user joins the group, for example, we have to put it into these two places, and also remove it when he leaves the group. Okay, so let's move to a second challenge we were facing. So it's how can presenter survive configuration change? Like configuration change on Android, is this like problem that everybody is solving with different libraries, and there are multiple approaches to this, how to survive configuration change. Configuration change is usually rotation, but not just rotation. There are more configuration changes, like when user changes language or font, or opens keyboard, or goes to a multi-window in Android N. So you should really care about configuration changes. It doesn't usually solve it if you just disable rotation. And the architecture needs to come with that. So we have the presenter, which holds the data for the screen and also loads the data and everything. And like you don't want to lose the data after rotation. So how to do it? So here is some code from our base fragment. And we are using loaders for this. Loaders is Android component specifically made for this purpose. So for surviving configuration change, loading something, and it's nice that after configuration change you get the same instance of the loader. Loader gave you the cache data, but when the user goes out of your app, so for example when he presses back button or home button, the reference is go away. So you exactly want this behavior. So interesting part here is this attach view method. We use it for, we call it on the presenter to set up the view. So presenter already has the data, and here you attach data to the view. So view is activity or fragment. And this is how the presenter looks like. So we have this presenter. It's quite really simple. It just here either delivers the result immediately, or it loads. It starts the loading based on if the presenter already has the presenter or not. It creates the presenter using some factory method, and then it calls on created by loader method in the presenter, and the presenter in this method he loads the data. So he calls Firebase and all this stuff. Also, you cannot really see it here because of my laptop. Sorry, I will tweet a link to this presentation later, so you can see the links. But here are the links to more detailed documentation and articles about this, because this is a simplified example. I just want to show you the principles. But if you want to dive deeper into this topic, there's links to articles, which is our source. So now quite a big challenge we are facing, because I talked about this Firebase structure that you have to flatten your data. That means for one screen you have to do multiple requests to Firebase. You have to go to multiple places in Firebase to then build all the data you need for displaying in one screen. So how to coordinate multiple asynchronous calls to Firebase? With Firebase, everything is asynchronous. All the APIs for Firebase is asynchronous. So you have to think a little bit differently when you are developing your app. Because anything can change at any time. It's real time, so it's not just loading the data for the first time and displaying it in a view, but it can change anytime user is on that screen and you have listeners there. And for this we are using RX Java or RX Reactive Extensions, RX Kotlin, RX Android. It's a really powerful tool specifically made for this. If you have a lot of asynchronous call and you want to coordinate them, it's really great, saves you a lot of pain. So here is a method we are using for wrapping the Firebase API into reactive manner, because Firebase API doesn't have reactive extensions by default, but it's quite easy to wrap their API. So we are using this method from async, which is made specifically for this. If you have some like non-reactive API and you want to make it reactive, that means like you want to generate observables. So this is part of Firebase API, add value listener to some path in Firebase, and when it gets the data, it calls this method on data change, and you get this data snapshot which contains the data, and we call it on next, which is classic RX call on next. It also handles cancellation. So when somebody unsubscribes from this observable, it calls this cancellation, so it will remove the listener from Firebase. This is Firebase API. It also handles back pressure. I will not go into details, but it works with multiple threads and stuff. So now how we use this method, I showed you before, this observe. So we have you can see some advantages of Kotlin here. So object, that's like singleton in Java. So it's really easy to create singleton. This is accessible from everywhere in the app. if we just call database read dot something. So we have this singleton, and you can access paths in Firebase. So for example, if you want to get user group color, what the user's color of the group is, you pass the group ID. Here's the path in Firebase, so user groups, then like user ID of the current user, group ID, and color. We call this observe method I showed you earlier. And then we have this extension function. That's another feature of Kotlin, which is really nice. These methods are for transforming the data snapshot, because this gives you observable of data snapshots, but you want a specific object. Like you want a string here, you want member, which is like a data class. Here is something more specific. So you can see that it's quite simple. So now I want to show you how we load it in the presenter. We need to load this in the presenter. So this code is in our base presenter. So we only had to write this once. All this code you've seen before, we had to just write once. So we have this load method. You put this observable, which is from the previous slide. Like you get this from the database read, and you pass function. Kotlin allows you to give functions as parameter, and this is for displaying the data into the view. You can see here that we cache the values for configuration change, and it automatically does when you rotate the display. It doesn't go to Firebase again. All the data is saved here in the cached value. So automatically when you rotate, it just calls this display to view. And it doesn't go to Firebase at all. We have similar method for loading multiple stuff, and because sometimes for one screen or some part of the UI, for example, list of transactions, but you also need like members, because in the UI the list also have members, like icons of the people. So you want for this one screen, you need both at the same time, the transactions and members. So you use this load multiple method, and you can pass list of observables, so not just one but a list, and you get like array back. And we are using this combine latest feature from RxJava. So what it does is that it waits until all the observables gives you result, and then it calls this method. So this display to view is called only when you get all the data from all. It waits for all the asynchronous calls, and what's nice about it, that it also when anything changes in like members or transactions, it calls this method again. So when members change, it's called. If transactions change, it's called. So you don't have to care about it. It's also automatically unsubscribing. So like if you unsubscribe from like this combined stuff, it unsubscribes from all of it. So now let's see some concrete example how we are using this code. Like before, what you saw was more like base fragments and like under the hood, but now some concrete example from our code. So this is screen we want to create. This is our member details screen. So in the app, you go there, you can edit like the member there, his bank account. You can click this is me. Like that means signed in user is this member. Here's color of the group, and here you can see the data from Firebase we'll be using for this call. So for constructing this screen, we need to query 3 places in Firebase. We have to go to members, which contains this data you can see here. Also, we have to go to user groups and colors. So because we need this blue color, or this blue color, it's changing for each group, so we need this color. And also we have this member users, which is a relation between members and users, because one member can be multiple users. That's why it's separated here. So we need it's needed for this is me check. So we need to query this 3 places, and let's see the code. So here is our presenter, and it has these parameters, group ID and member ID. It's quite straightforward. It's inheriting from base presenter, which is doing all the work. And in this onCreatedByLoader method, we called load once, and in parallel, we load this two in parallel. But this is a load multiple, so it first loads this two, and then it's called this method. So you can see both approaches. So for group color, we are using just the load once method, and here it's loading list of two observables. And we call the view, and we just set the group color. So we just pass the data into the view. View in this case is activity. So let's see the activity. This is the activity. And as you can see, the activity is pretty dumb. Like that's the main point behind MVP. Activity should not do any logic. Then if there is no logic, you don't really need to test it, because testing activities is quite hard. You can test it just with like UI testing, but testing the logic should be done on the presenter. So these two methods bind the layout. So this is the layout, and this binds the presenter. And we have in the base activity, it does all the work for us. So like it inflates that layout and also etc. It calls the loader, and these methods are called from the presenter: set member, set group color, and it's really dumb. It just sets this is text view, so it sets text on this text view. One nice feature of Kotlin is that it automatically creates this references, this text view. We have naming convention, that's just our naming convention, that it starts with V, like view. You don't need to use that. But you don't need to do this find view by ID or using some other library. Kotlin does this for you, that it automatically creates you variables, and this is based on the ID in the layout. So the ID in the layout is called vName. So that's it. We are getting to close of my presentation, and now I want to talk a little bit about monetization. I always have a lot of questions about how much does it cost. So there are multiple things that like you have to pay for, but for us, it's mostly these two. So when you're storing data into real-time database, it costs $5 monthly per stored gigabyte. And if you are storing something in Firebase storage, it's this. So you can see it's a huge difference. The Firebase real-time database is quite costly, and it like increases every month. Like it's not just data you saved in that month, but totally. So you have to really think about monetization here, because right now we are making money just from new users. Like on iOS, our monetization is paid up only. You have to buy it. So we are making money just from new users. But if new users decline for some reason, then we get less money. But still, we have to support the old users, and we will be still paying this every month. So then we could run into trouble. So I think when you are using Firebase or similar services, you really have to think about monetization also the existing users, not just the new users. So here's again link about detailed pricing you can check out later. So one trick, what you can do, you can see that this is really cheaper storage. So real-time database, it's not really meant for like non-real-time data. For data that user doesn't need right now. Maybe some like historical data, some archives, like 1-year-old data. You don't have to save it to real-time database. It's a waste of space. So what we do is we allow user to migrate some old data into storage. We just all the real-time database behaves like JSON, so we just take this JSON and we put this JSON into storage. That means user cannot access the data in the app, but it's okay because it's some archive, and when he wants, he can grab data from archive, put it back into the app, and then use it. And we tie this with monetization. So we basically we basically monetize based on number of transactions user has in Firebase. Like, we don't, of course, say this to user because users don't know what Firebase is. But what number of transactions are there? So there is like some limit for number of transactions you can enter. There is some free limit. So I don't know. We don't have the numbers finalized. Like, for example, first 200 transactions you can enter there for free, and then if you are over this limit, you can either watch some video ad to increase the limit just by few, or you can buy in-app purchase, increase this permanently. What's really nice that we can work with this limit like in-app currency. So we can, for example, reward some people who bring new users to our app. We can reward them, or if they are helping us some other way, like translating or something. And we can also migrate from previous monetization, because currently we have different in-app purchases, something different. So if user already paid us some money, we will just increase his limit. So it's fair. So I hope users will not complain after the switch. And also there are some users who just like don't care much about money and like don't want to deal with anything. So for them is a subscription. So if they sign up for subscription, all limits will be huge, and like they don't have to care about anything. So in this way we are monetizing three types of users. One, users will not pay anything ever because like they don't have credit card, or they live in some country where it's not possible. So they can watch the ads. Some people who care about their money more, but sometimes they are willing to pay something a little bit, so they can manage this with in-app purchases, and it's directly tied with our Firebase bill, so we will not run into problems when we have a lot of data in Firebase and nobody's paying for it. And for some maybe richer users, there is subscription. Okay, and now about Windows support, because Google is always saying Firebase is great, Android, iOS, and web. We support all the platforms, but what about Windows, right? We have also Windows app. We have really enthusiastic Windows developer. And so what we did is we wrote our own libraries. And we open source them, so you can use them too. Here is some links to our GitHub. We have the library for Firebase real-time database in .NET, and also Firebase authentication in .NET. And we are working on Firebase storage for .NET as well. So if you are using Windows, use our libraries, send us pull requests, star us. Okay, so that's it from my talk. Thank you, and we can move on to some questions. Yeah, I will read it. Okay, so first question, where are your Google Glass? So maybe some of you know I was in talk show from Kraus with Google Glass. It was great. I don't have them now. I sold them because Google is moving on to other things. Like this is no longer like a cool gadget. They are still testing Google Glass with companies, but probably not consumers. So I moved to other things. I will not comment politics. About web interface for a settle app, current version has many bugs. So I don't know about them. Please, whoever wrote it, we have a Google group for feedback. Please write us what bugs does it have. We will fix it. Actually, the main organizer for this DevFest, Filip Procházka, here is our web developer. He's working on it. And we are trying to create, using all these new technologies, like progressive web app, notification service worker. So it's quite cutting edge technologies. That's maybe why the bugs are there, but we are working on it hard. Kotlin looks like fun. Yeah, fun. Yeah, fun. Functions are fun. But I don't understand this question. Maybe. Yeah, statement. Yeah, so it looks like this. Yeah. Can I contribute to beta testing of new design? Yes, please send me email, and I will add you to this supporters group we have. Like, we are not ready for alpha testing yet, but we will be in a few months. So you can test the new design and give us feedback. We'll be very grateful for the feedback. Send me email, or you can find it online, or tweet me, or hangout me, or whatever. If you change your profile pic on Google, does your picture automatically change too? So no, we designed it that the user should be more in control, and you can also upload your own picture. So we just when you sign it for the first time, it takes the picture from Google or Facebook or from the provider, but then it stays, and user have to change. We'll see if users will want that, but currently no. Why is iOS paid and Android app is free? So it's more from historical reasons, because historically iOS app was developed by somebody else, not me. I just opened API to my backend, and these guys from company called Bioport created app and made money on it, and like they decided that it would be paid. But we want to change this, and the monetization will be same on all platforms with the new release. Did you contribute to Kotlin? No, I just like to talk about it. How did you become Google expert for Android? So this program, like anybody can join it, but usually you need a recommendation from some existing expert. So if you think you are up to it, send me email. We can talk. And you need to have some experience in the field, like Android, Firebase, cloud platform, or there are even like marketing experts, UX experts. It's quite broad. Check the website. And I think what helped me personally is that I was GDG organizers for many years. So I think the first step is to GDE is to become GDG organizer, help GDG organize events like this, and then it's much easier to become GDE. It has quite a lot of perks. Google is paying me to go to different countries to speak at conferences. I was in Africa a month ago. It was a nice experience. Roughly how much data can be stored in 1 gigabyte of Fireball? I guess Firebase. So quite a lot. We estimate that like all our current data will fit into like 2 gigabytes of Firebase storage, which is a lot of users, lot of transactions. Like we have 200,000 active users. So I don't know specific number of transactions, but what we have to do is we have to migrate just the data which are recent, which people are using. We will not be migrating all of the data. We will actually involve users in deciding what groups they want to migrate and what they want to stay in the old backend. So because they are like 5-year-old groups, they will not use it anyway. They have it just for archive, so they can leave it on the old backend where it's cheap for us. Okay. Yeah, thank you. I will also tweet the link. Yeah.